We are at the Austrian Army National Proving Ground in Felixdorf, Austria, and this is lab test number 5. Lab test number 5 has two objectives. The first one is to demonstrate that the points of critique discovered during lab test number 2 have been compensated and corrected. And objective number 2 is the testing of the transport drone, the ground penetrating radar drone, and the modeling swarm drone. Over the next 2 days we will test each of these drone types, see whether they're fulfilling the expected requirements and to whether there are any gaps that need to be addressed in the future. The team operating the drone consists of the pilot and of the operator. The pilot has the responsibility to fill in the drone pilot logbook, which describes anything from the flight and safety features of this mission to the weather conditions, wind direction, and the description of the flight path and mission task. Secondly, the operator fills in the checklist, and the checklist indicates to ensure that the pilot and operator team have not overlooked any of the important features that are typical for the mission that they to conduct. So they go through the checklist and tick off each task that has been fulfilled for flight preparation. The following tests includes the ground penetrating radar drone, GPRD. This drone system consists of a ground penetrating radar unit in a box underneath the drone, and the connection between the two units is done through a cable that is operated by a remotely controlled winch. For the transport of the radar unit and the drone, special containers have been developed which fit onto the EUR Europe standard pallet. The background behind me shows the original radar unit and the modified radar unit. The difference is the weight. We were able to reduce the original weight of 12 kilogram down to 3.5 kilogram. The ground penetrating radar drone is transporting the GPR to every test pile. Every test pile is a consistent construction material ranging from brick in coarse and fine mode to gravel in coarse and fine mode to concrete and wood. And at each time a radiogram is taken by the ground penetrating radar with the dummy, the breathing dummy, underneath the pile. An essential component of the GPRD test is the breathing dummy. This dummy contains an electrically operated quote-unquote chest which simulates the breathing action of a buried victim. The breathing frequency can be modified and results in a lifting and sinking, lowering of the chest of the dummy, and the frequency is indicated by a flashing red light in the neck region. Major efforts have been undertaken to improve the redundancy of the drones in general and of the GPRD in particular. The landing gear has been modified to withstand a hard landing as compared to a regular landing undamaged, and this has been tested on frozen hard snow at -10 degrees centigrade, and up to 4 hard landings the landing gear can sustain undamaged. This radar drone has a special winch that has been developed with a pulling weight of the rope up to 40 kilos. So the break point is never reached if it carries a 3.5 kilogram radar unit. The drone has, like all the others, a very strong LED light. This drone has a megaphone to communicate with the people, buried underneath a pile or communicating with the first responders. A special holder for camera and thermal camera. This is the pilot camera as such. The whole unit is in a specially made box, transport container, to fit the drone and to fit onto the Europal pallets. The landing gear as such consists of the snap-on pull-off quick fixation, a carbon fiber reinforced strut at the bottom of the landing gear, and that in itself has a flexible unit, so that when the landing gear is under stress, this can expand to avoid further damage. The inside of a drone is rather complex, firstly due to the originally installed hardware, and secondly because of the redundancy required by the authorities. This is shown by the flight control, which is present in 2 forms. One is the original flight control as installed by the manufacturer, and the other one is the additional redundant flight control as shown in here, and this is also reflected by the control lights on the master unit and the slave unit. An additional safety feature in terms of redundancy is the dual protection against electric shortcuts, as shown with these 2 units with the cooling surfaces. Once all requirements issued by the authorities have been met, a legal label is issued indicating who's responsible, who's the owner, and the flight authorization for the particular drone. The drone is almost flight ready now. The next step will be the installation of the power pack, the batteries, then the magnetic compass calibration, and then the readiness for the drone is complete.
Erklärbär. Sie haben zwei Gehirne neben sich, die jetzt aufpassen, dass dort der Zaun außen. Wird das sein, dass es so passt, oder?
Geht.
Weißt du, was ist so schwer daran zu verstehen? Und vor allem, das ist gleich.
The objective of the ground-penetrating radar drone is to detect potential survivors underneath debris. This breathing dummy will be located underneath a test pile, and the radar drone will fly to the test pile, and we will be able to tell from the signal whether there's a breathing person underneath or not.
Drohne soll im Hintergrund sein, oder?
Ja. Okay, das wird es.
Naja, sicher.
Nicht drin sein.
Hat das halt.
Noch ein bisschen geneigter. Ja.
Although the batteries are special lithium batteries with a high capacity, it is possible for the operator to change the battery set with just a few motions upon opening the lid of the drone. The modeling swarm drone consists of 5 drones which operate independently, autonomously along a pre-programmed flight path. Hundreds of photos of the area to be modeled are stored on an SD card. Upon landing, this SD card is removed from the drone and transferred to a computer where algorithms will create an orthophoto after a relatively short time of 30 minutes or a sophisticated 3D model with calculation times of about 2 hours. In the container, the 5 drones together with the 5 control units are stored together, ready for takeoff.
Schreibe noch hin, Route A, B, C, D, E und jetzt der Mood.
After finishing their flight programs from the 5 drones, the SD cards are taken out of the drone and transferred to the workstation on the ground for subsequent calculation of the orthophoto or 3D model. In the following test, the transport drone will be loaded with a equivalent to the original Smurf, the ground robot, and a dummy ground robot for the test. The dummy robot has the same weight as the original Smurf will have. The Smurf will be flown by the transport drone to the point of destination defined by the crisis management and unloaded from a maximum height of 1 meter above ground.
Good.
The inside of the transport drone shows us the mounting mechanism for the camera and most importantly the release mechanism for the Smurfs. They operate under remote control wirelessly. We also see the LED light illuminating the area and the megaphone for communicating with the personnel on the ground.
Also mir ist das vorstellen. Das ist perfekt. Es geht schon. Auch wenn wir ihre Aufnahme gespielt. Die haben aber jetzt mit dem ganzen Modell das uns mitgezogen. Keine Ahnung, wie man ich habe jetzt damit alle Sachen in mein Auto eingepackt, wenn man die Hütte kann. Ja, das hilft vielleicht auch.
The transport drone is now ready for launch, and it will be equipped with simulated ground robots. We've come to the end of the 2 days of testing within the framework of the lab test number 5. We're here at the proving ground of the Austrian Army in Felixdorf, Austria, where the Army has built 5 defined test cones, each of a defined building material and defined density of the material. We have tested the ground penetrating radar drone. We have tested the transport drone delivering the Smurfs to the particular sites. And we've tested the modeling swarm drones with the task of creating an orthophoto or a 3D model of the test site. The conclusion of the measurement results will be presented in a report, and the film that will be made can be used for training purposes and for communication activities within the framework of the Cursor project.